Hello again. Thank you for joining our session. I'm Kazuaki Harada from NTT Communications. Today, I'll give you a presentation about our cloud-native use case challenges. Okay. I hope that by end of this presentation, you will understand three things. First, you will understand the differences between the private cloud, hybrid cloud, and public cloud. And the second, you will know the challenges you face when using cloud-native technologies. And finally, you will know that these are several solutions to the above problems. Here is the index today's slide. First, we would like to introduce ourselves. Then we will talk about the cloud-native overview. And next, we will share our cloud-native use case. And then we would like to share some cloud-native problems via our experience. And finally, we conclude. Let me start by introducing myself. I'm Kazuaki Harada from NTT Communications. I'm an infrastructure engineer, and my work is managing Kubernetes infrastructure for in-house use. Then I'm also responsible for advocating cloud-native deployments. And my favorite technology is Kubernetes, container, CI/CD, and Python. And since then, my hobbies have been camping, sketching, programming, and so on. Next, let me introduce our company. Our company, NTT Group, is a well-known NTT Group is well-known telecommunication and telephone company in Japan. And my company, NTT Communications, is here. And now, for some recent news, NTT Communications is now a subsidiary of DOCOMO. Therefore, our logo has changed from the previous one. And DOCOMO's primary services is cell phone. But our company's services are international communication. Let me explain in the next slide. Our company provides a variety of services centered on network and telecommunication. So our company has physical fiber, submarine cables, and facilities for internet communications, and has developed various services and solutions to go along with them. These are part of our several services. We offer an interconnected service as well as we provide our cloud and hosting service. About IoT, we offer IoT platform like Things Cloud and SIM card for IoT devices. Since then, Node AI has been a service that enables the development of AI models from the browser with Node code. Please keep in mind that Node AI will appear in the slide that follow. Now, let me talk about cloud-native overview. First of all, what is cloud-native? Wikipedia said cloud-native computing is an approach in software development that utilizes cloud computing to build and run scalable applications in modern dynamic environments such as public, private, and hybrid clouds. So, what exactly are public, private, and hybrid cloud? So, on-premise cloud is the same as traditional on-premise. When you operate your equipment as shown in the figure on the left, okay, the difference is that it is modern and more scalable with a container infrastructure like Kubernetes. Of course, I'm sure there are some exceptions. Hosting type cloud services vary depending on the company that provide the service. Some company create their cloud environment in a data center supplied by the hosting company, while other deploy the service providers' appliances in their own data center environment. Both on-premise and hosted cloud are closed only to the company, and the company can freely configure them. However, the company must develop and implement the necessary functions in-house, and operation is typically done in-house. Therefore, if you want to build a private cloud, it is better to prepare a team that can operate it. Public clouds are familiar to everyone. It is like Microsoft Azure, Google Cloud Platform, Amazon Web Service. There is nothing special to mention. However, there are some differences compared to the private cloud. For example, you can use Lambda, Cloud SQL, and S3. Various services that make development convenient are already built into the cloud, and developers can use them in combination. The next is hybrid cloud, an appliance provided by the public cloud provider, deployed in your own data center or another location. Examples include Azure Stacks, Google Anthos, or AWS Outposts. One of the features is that products provided by cloud provider can be used without an internet access. For example, a company that has the data that it does not want to share with the outside world can use a hybrid cloud to provide services such as Lambda and S3 within its network, which previously would not be available without internet access. Next, we will introduce the use case of each cloud. Let's start with our private cloud environment. My team provides container-based GPU infrastructure for in-house engineers. The cluster has three environments: production environment, staging environment, and labo environment. With the first two built by Adam, the lab uses Azure AKS. As for how each is used, the production environment is mainly used for machine learning. We have in-house storage so that we can handle sensitive information. And now Node AI team use this platform for development. Staging the environment is a cluster used for upgrading production environment and checking the operation for applications. It is built to resemble the production environment. The lab environment is a sandbox for operators, and it's used for testing open source software and multi-cluster integration function provided by Microsoft, such as Azure Arc. Next, here are some examples of our use of public cloud. Okay, we would like to introduce Kumonas value stream as an example. Kumonas is a DevOps platform that enables application developers to deliver features and services that are valuable to users continuously. With Kumonas value stream, application developer can easily reuse cloud architecture best practice to deliver their application without cloud or CI/CD skills. The Kumonas value stream use multiple GCP products and SaaS to build the system. The core functionality is all built on the Google Kubernetes engine, GKE. On GKE, we run API servers for crucial functionality, Kubernetes custom operators for CI/CD functionality, and Loki for logging infrastructure. Kumonas define the custom resource called assembly line to configure the CI/CD pipeline. We also use BigQuery, Cloud Load Balancing, and Cloud Armor. By processing CI/CD task event logs stored in BigQuery, users can check DevOps metrics such as deployment frequency by themselves. As for SaaS, we have Auth0 and Cloudflare. Kumonas combine the above to build a cloud-native system. Finally, here are some examples of hybrid cloud applications. As a hybrid cloud, each cloud provider offers products such as AWS Outposts, Azure Arc, and GCP Answers. Today, we focus on Azure Outposts. There are 4 advantages of using Outposts to create an on-premise data lake. The first is the built-in storage and data analysis infrastructure is accessible. AWS Outpost has an S3 that can store extensive data without predetermining the data size. In addition, it is possible to create parallel distributed infrastructure that scale flexibility by using auto-scaling group. Second, AWS Outpost is fully managed infrastructure and AWS managed everything. The third is security measures. AWS IAM can manage all resources running on AWS Outposts. This IAM allows for a high level of protection. Finally, it can centrally handle large-scale data that requires low latency or is highly confidential in our on-premise environment. Next, we will introduce the architecture of the data lake. The architecture of the data lake is as follows. First, several IoT sensors send data to AWS Outpost, which can communicate with the on-premise environment using the local gateway. Next, for the data lake, we use Delta Lake, and this storage layer is executed by Spark built in parallel using auto-scaling group. This auto-scaling group enables large-scale data to be stored and processed while ensuring scalability. Data processed by data leg is stored in S3 on outposts. As of August 2022, the maximum amount of data stored in S3 in outpost in 380 terabytes. Next, we would like to share some of the challenges we have faced in cloud native. To begin with, our private cloud is costly to upgrade. For example, when we try to upgrade Flow, it is not easy upgrade because of istio version and cluster version dependencies. Besides, the release cycle of Kubernetes is high speed, and it takes a lot of effort to catch up. Here is what our team is working on as a solution. First, as a primary example, we are building a team to manage a private cloud cluster and preparing a staging environment in advance. We are also using Ansible to ease the configuration of the nodes that make up the cluster. Moreover, it is essential to check the version of the currently used components in advance to identify any version dependencies. Then it is important to determine which services to focus on when upgrading. And finally, I especially recommend writing cluster test. As a cluster test, we use Ginkgo and Teratest for end-to-end testing. Ginkgo is a BDD testing framework available in the Go language. And Teratest is a Go library that provides pattern and helper functions for testing infrastructure, and it supports Terraform, Kubernetes, AWS, and more. This code is an example of applying the manifest and waiting until the service is enabled before testing the HTTP request. Using the testing framework, we verify that each node can correctly allocate the GPU to the pod and that the pod work appropriately. Next, we introduce the problem common to all clouds. The first of the is that if you have multiple clusters, you quickly lose track of them. The solution is to have a mono repository of deployments to manage them customized. Our team uses Customize to set up diffs based on the base manifest. The next problem is that you don't know who created the VM and don't know whether to stop it. To solve this problem, we have implemented Slack notification of who start EC2 instance and automatically assign tags to instance. The last problem was that we did not realize there was a security hole. This one was solved with Slack notification using guard duty and Lambda. If you are using Kubernetes, using starboard operator and Chuibi for periodic image scans would also be helpful. And then there is a problem specific to hybrid cloud. It's more expensive than private cloud. Even if you adopt a hybrid cloud, you will always need one maintenance person. There is no effective remedy of this problem. However, if you consider the total running cost, such as operational and security costs, you may find it affordable. The last problem will be the one related to the public cloud. Public cloud can change the version of their products and services at any time they like. That means one day your application may suddenly stop working. To prevent this, you will need to run tests regularly. This means that you will have to write tests. By having tests, you can immediately estimate the impact when an alpha version or another version is released. You also need to device way to have Slack notify your release notes so that you don't miss them. This is a summary. We talk about each cloud overview, and next we talk about our CloudNet use case. And we share some cloud native problems via our experiences, and it's maybe a little basic, but we hope this information will will be useful for when you use the cloud. That's it. Thank you for joining our session.
先ほどハイブリッドクラウドのところの説明があったと思うんですけど、基本的に AWS のアウトポストをそのままバニラで使ってるっていうふうに見えたんですけど、LTD コミュニケーションさんでいうところのハイブリッドクラウドって、そのパブリッククラウドが出してる提供するサービス、オンプレと連携するパブリッククラウドのサービスを使うってことでいいんでしょうか？ So my question is that before seeing your slide as a definition of hybrid cloud, it sounds like more like a vanilla public cloud service offering onto the on-premise hardware and manage the service on their public cloud, which is AWS Outpost or Azure Stack or Anthos, something like that. So mainly my definition for the public cloud, hybrid cloud should be on-premise offering, on-premise cluster or cluster in order to reduce the cost, but sometimes you have to leverage the public cloud so disaster recovery or something like that. So that's quite different from my understanding, but is that your definition?
Yeah.
That's my question.
At this point, we don't use Outpost in our cloud, which provided the company, and this use case is just researching for CloudNet use case for now.
So you're researching AWS Outpost as a hybrid cloud. Okay, thanks so much.
So, next questions? No? Yes. So, thank you very much, Harada-san.
Thank you.
Very good discussion and good question. Thank you very much.